Hi, ElectroBOOM channel finally reached 5 million subscribers, all thanks to you. If it wasn't for you liking my videos, I would be probably at the corner of some lab sniffing solder fumes. Now, I just sniff solder fumes at home. So thank you! And it took us a little bit less than 10 years. So now we have to celebrate with a great project and a massive giveaway of 4 3D printers thanks to Lulzbot for providing them. A Taz Psychic, a Mini 2, a Taz Workhorse and a Taz Pro S. Watch to the end if you want one. Do you remember my high voltage DC magic wand I made a while back? Now I want to make a super high voltage AC magic wand. Basically, I want to make a portable Tesla coil, which is quite simple. All we need is a piece of wood like this as the handle of the wand. Then we just need a tad bit of duct tape to connect our Tesla coil to the piece of wood. And there we have it. There we are. Let me increase the power. Increase the frequency. Oh yeah! Look at this. It's beautiful. Now I have a magic wand. Alakazam! Too much noise. I'll do voiceover here. What the hell? My thing just turned on. What is going on? Why is my table rising? Oh, ha ha ha! I have actual magic powers. Come on, stop. My god, you little buffoon. I'm joking. I'm going to make a proper magic wand. I feel like I might be making a failure. Which is probably something my parents said when they were debating about having me. No, what really? These magnificent arcs require such dimensions and big circuits, and to fit them inside a tiny magic wand sounds impossible. Well, let's try it anyways. We may not get any magnificent arcs, but we can at least make the wand beautiful. Well, let me explain the plan to you. Well, I was thinking, I bought one of these touch monitor thingies that you can draw on. Maybe it's time to replace my stupid whiteboard. Although I don't want to lose the whiteboard. It has nostalgic values. Let me see what I can do. I'll wear my green shirt backwards so it's blank and comes all the way up my neck. I use my Elgato green screen. Set up my drawing thingy here, and I'll pop a headless picture of me on the screen. There we are, and now I can draw anything I want on the memory of my whiteboard. Okay, so a Tesla coil is generally a pretty bad transformer. And it's its badness that makes it great. With a primary coil, a secondary coil, and a big metal toroid on top called a top load. The large metal top load creates a parasitic capacitance to the environment and earth. And of course the secondary coil has an inductance. And together they create a resonance frequency. And Tesla coil is a transformer that works in resonance mode. So this means if we actuate the primary at the same resonance frequency as the secondary, the output energy builds up over time, creating huge voltages. So you see, the resonance frequency is dependent to the inductance and capacitance of the secondary. The larger the top load, the larger the capacitance, and the larger the inductor, the larger the inductance. And this poses a problem for our magic wand. See, we are restricted by the dimensions of our magic wand because, well, we want it to look like a magic wand. See, the secondary winding will be thin and long, and the secondary top load can only be a tiny ball. And I guess the primary coil will be very tightly wound around the secondary, which is bad too. So basically we have a small inductance and a small capacitance, which will both contribute to a much higher resonance frequency, and it makes it much harder to drive the circuit. Well, let's make the coil itself and then we'll see if we can drive it at all. So here's the plan. First, I will 3D print a thin and long pipe to use as my secondary. For ease of printing, I designed it as 2 separate half pipes that I will glue together. Save my model on USB and let's start printing. Wow, I put off using it for so long. I thought it would be much more complicated to use. What's so easy to set up and run, and it's noiseless compared to my last one. I guess I'll see you in 15 hours. Finally. Now we carefully try to peel it off. Have to remove the support structures. And now we chop it and put it in the salad. Then we glue the two pieces together using crazy glue and hold them together with tapes while they dry, like so. Then we remove some uneven edges and sand it to make it as smooth as your brains. Apologies. Then I'll 3D print a tiny piece that will hold my top load ball. I bought some steel balls, I just need one of them to use as my top load. Here it is printing. A beautiful art is a result that will tightly hold your balls and goes to the end of the rod. Apologies. Then I'll wind my secondary coil. I use 28 gauge wires for over 700 turns. Then I place the ball holder on top and pass the end of the wire through it and connect the wire to the ball somehow and then glue the ball to the holder. Here I'm using a spring connected to the end of the wire, then I use crazy glue and push the ball against the spring and hold it until it dries. Then we need to wind a few primary windings right on the secondary, which frightens me. The reason is that the primary windings are at much lower voltage than the secondary, so it can easily break through the insulation and arc between the wires. So I have a plan. I am going to 3D print a container to put on the secondary and fill it with epoxy. And hopefully this additional layer will provide enough insulation between primary and secondary. Here is the part being 3D printed, and I put the two pieces together and weld them together using hot temperature, like so. And then I fill the part with epoxy and let it dry. And while I'm at it, I epoxy the secondary too for protection and electrical isolation. And I guess here the table is getting a free coating of epoxy too. And then I'll rotate it for hours until it dries evenly. Now we are making the primary winding, bending it into shape using 10 gauge wire. And I bend and form. I didn't come all the way from Iran to state the obvious. I put it on the place, I guess. Then I use the wire jackets to create insulation for primary so that its wires don't touch each other. Like so. I think that was smart. Now there's a typical problem with Tesla coils that if you look right there, a lot of magnetic fields don't pass through the entire length of the secondary or at all. This means you have poor coupling between primary and secondary windings, and you have to create a ton of reactive power in primary so that some of it converts to real power in secondary. Now reactive power is not a waste in itself, but to create it, you have to generate a ton of waste over the driving components. And that's when generating a ton of reactive power becomes a problem. The reason for this bad coupling between primary and secondary windings is that, unlike other transformers, Tesla coils don't use ferromagnetic cores and only use air core, which is a piece of junk when it comes to cores. The reason we use air core is simple though. If we actually use a conductive ferromagnetic core for our Tesla coil, because the voltage across the secondary of Tesla coil is huge, having such conductive core places super high voltages very close to each other, and so the voltage will arc through the insulation of wires and short the coil. I did see this when I was running my Tesla coil in vacuum, which melted my secondary, all because I accidentally ran a screw too deep inside the secondary. I was holding my top load with a screw that was going too deep inside the secondary, and the voltage between these two parts was high enough that in vacuum my screw arced to my winding and melted the whole thing. But my dudes, I may not have much choice. The inductance and capacitance here might be so small that the resonance frequency would be too high to be easily drivable. If I use some sort of ferrite core, I can increase my inductance, which in return reduces my resonance frequency. Easier to drive. Not only that, a core will focus the magnetic fields inside the secondary and further up the winding, which means a larger energy transfer and hopefully a much larger voltage. But of course, we have the problem of shorting high voltage. So here's the plan. I bought a bunch of short ferrite beads. I will place these beads at a distance of around half a centimeter to each other, and then I will encase the whole thing in epoxy. The goal is that not only this is not a continuous core, so it doesn't place super high voltages close to each other, but also all the gaps between them and around them is covered with epoxy that should provide a very good insulator against high voltage arcing through it. I'm using a clear sheet to create a mold for the epoxy and the beads, like so. Then I use a 2-part epoxy. I pour equal parts and mix them until clear. And then I put them in a vacuum chamber to debobulate. Then I pour the epoxy and place the beads inside. Then I space them half a centimeter, and after drying, look at the beauty that comes out. But we are not done. I'll print a mold for the epoxy because I want to make it even thicker. I place my rod inside and let it dry. Then I take it out of the mold by melting the mold. I broke the end of my rod, but that's okay, I'll glue it back. Now we sand my special core so it fits in my wand. Now that I made my specialized core, it's time to see if the insulation is any good, and for that I'm gonna use my Tesla coil. If there's anything that can break through the insulation, it's these high voltage arcs. Let's try it. It's not jump out! It jumped, but it jumped over the surface, not through the beads. Ow! 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 Yeah, it just creeps over the surface. Here I put a ground connection and I'll use faster pulses to see where exactly they go. Here we go. See? It jumps over the surface and doesn't go through the beads. So I say installation approved. And of course, then I will cover the whole thing in a layer of epoxy. The reason is that the primary winding right here, right here, is too close to the high voltage secondary winding here. That scares me. And hopefully adding epoxy on all of it provides enough insulation to prevent arcing between the two windings. This time I got smart. Instead of turning my wand for hours, I connect it to a magnet and on the other side to a DC motor. Hold it in place, turn it on, and it will turn on its own. Then I pour epoxy on it, and the rotation makes it very even. Increasing the speed makes it even more evenly distributed. I increase the number of magnets to 5 to make it more secure and stable. And it is beautiful. It is done. The thing is that I had no control over the values of inductance and capacitance, and the whole thing was pretty much driven by the shape of the wand that I wanted to get. And really, the value of capacitance is also kind of random too and depends on the environment around the wand. Like if I bring my hand close, it will change the capacitance. Well, at least it looks good. Let's see if we can drive it now. Look at this beauty. It's time to test it. First, I'm gonna drive it with my Slayer exciter circuit you may remember from a long ago. Here's my wand taped to a cardboard box and I'll run it up 20 volts. No explosions. No arcs either though, as expected. Let's see if I can create... Ooh! The radiation is interfering with my table, so I guess it works. Table is offline. Let's turn it on and try a broken fluorescent lamp and see if it turns on. Oh, there you go. Yeah, quite weak to my taste though. Maybe it's time to do some measurements and use my special core. Oh, I broke my lamp. Okay, I placed the probe close to the tip of the wand to pick up the radiations and show it on the scope. You turn it on, and you see there is around 2.6 megahertz signal coming out. That can change if I bring my hand close. Let's put my special core in. Here we are. The frequency drops and the output rises. Nice! Now the frequency is around 1.85 megahertz. So my core works, increases the inductance by around double, reduces the frequency and increases the output voltage. Let's use another lamp and see if it's brighter. Yes, it turns on earlier and is brighter. You know, I think I have a beefed up Slayer exciter. Let's use that one. Here's the beefed up version. Also, I drilled some holes on a piece of wood to hold my wand better. Here you go. Can I maybe get some arcs out of it? Ow! Did you see it? It burned. And here's the lamp. See? It turns on much brighter over a longer distance. No significant arcs though, unless I use my super strong circuit. And I would also need some sharp spike coming out of the head. Let's make something. I designed and printed this part, cut the extra pieces, passed the nail through it, and glued a neodymium magnet. And here we have our sharp spike. And here's my beloved old driver. Okay, here we are. Ow! Oh, you see that? Look at the fluffy plasma up there. And now the light turns on much more powerfully from a longer distance. This is beautiful. Oh, no. Look at this. Why is this so hot? The wire is so thick. Maybe there was some bubble under the epoxy and there was some internal arcing and the air expanded, melting the plastic and push it out. I have to fix it now. My art. Ah, that's fine. The wires are okay. I'll just cut the plastic open and refill it with epoxy and finish the one later. Now, let's celebrate!
Giveaway time!
Thanks to Loudsbot for providing me with this baby and 4 more to my viewers. This is some rugged beast made in USA, and depending on the model you get, they come with a ton of features like the self-leveling heated bed and very easy and quiet operation. Mine has been running reliably and the print quality was great. As long as you know how to 3D print, you know, there is a learning curve. But I think they did everything they could to shorten that learning curve. Now, not everyone needs a 3D printer, so to make it easy, if you need one, go to Twitter and follow Loudsbot3D and follow me too while you're at it. Then post a tweet tagging Loudsbot3D using hashtag ElectroBOOM and say why you need a 3D printer. And 1 week from now, you could be winning one of their great 3D printers. Again, thanks for pushing me up to 5 million subscribers and thanks for watching.